diagram below, ABC is a vertical triangular wall on the floor CBD, where CA is equal to 13 meters, okay? CD is equal to BD, it's indicated over here, is equal to K meters. Angle ACB is equal to alpha, okay? ACB is equal to alpha, and angle BDC is equal to 2 alpha. So we're asked to show that CB is equal to 13 cos alpha. So most likely we're going to use the cos trig ratio, okay? So cos alpha, remember our cos is adjacent over hypotenuse. Adjacent over hypotenuse. Now adjacent to alpha is CB, and then the hypotenuse is 13. Now we have to make CB the subject of the formula, so we're going to take this 13 across, so it's going to be 13 cos alpha is equal to CB. So we have done that. We have shown that CB is equal to 13 cos alpha. So we're asked to show that K is equal to 13 over 2 tan alpha for 4 marks, okay? Now what can we do from here? We need to find the value first of these two bases over here. And you can see this is actually an isosceles triangle because CD is equal to BD. So we have to find the value of angle BCD and angle DBC. Now these two angles are the same, so let's just name them X. So angle BCD is equal to angle CBD. Remember angle BCD, which is this one, it's equal to angle CBD, which is this one. Let's just name them X because they are the same. Now from here we can then say angle BCD plus angle CBD plus this 2 alpha. What do we get? We get 180 degrees. The reason for that is the sum of angles in a triangle add up to 180 degrees. Okay, so remember we said both these angles are X, so X plus 2 alpha is equal to 180. X plus X, that is 2X, okay, is equal to 180 minus 2 alpha. Let's divide everything by 2. X is equal to 180 degrees divided by 2, that is 90. 2 alpha divided by 2, that is alpha. So both these angles are 90 minus alpha. 90 minus alpha. 90 minus alpha. Now what we can do from here is, remember from the previous question we showed that CB is equal to 13 cos alpha, okay? Now so what we can do is we can then use the sine rule. So what does the sine rule say? The sine rule says A over sine A is equal to B over sine B. Okay, so our A stands for the length and our sine A is for the angle, both also the same for B. Okay, so from there we can then say our A in this case, let's just use this 13 cos alpha. 13 cos alpha divided by sine A. Our A in this case is 2 alpha is equal to, our B is K, right, divided by sine 90 minus alpha, remember, so 90 degrees minus alpha. Alright, so let's now simplify everything. 13 cos alpha divided by sine 2 alpha. Let's expand the denominator. Since this is a double angle, sine 2 alpha is a double angle, so let's expand it to 2 sine alpha cos alpha is equal to k over sine of 90 minus alpha will simplify to cos alpha. Now remember, we're trying to make k the subject of the formula, so let's take this cos alpha across. So it's going to be 13 cos alpha times cos alpha divided by 2 sine alpha cos alpha is equal to k. And then these two are going to cancel each other out. We're going to be left with 13 cos alpha over 2 sine alpha. Now remember, cos alpha over sine alpha should remind you of something. Now we are used to sine alpha over cos alpha is equal to tan alpha. But now if we reciprocate this, is going to be cos alpha over sine alpha, which is the same as 1 over tan alpha. So in this case, since these two have cancelled each other, I'm left with 13 cos alpha over sine alpha. It's basically 1 over tan alpha. So it's 13 divided by 2 tan alpha is equal to 2, which is exactly this question, which is what we're looking for. Sorry, not 2, what am I saying? It's equal to k, which is exactly this question that we're asked to prove. So we have proven that 13 over 2 tan alpha is equal to k. So we're now asked to calculate the area of the floor triangle BCD if alpha is equal to 26 degrees. So the area of a triangle, which is not a right angle triangle, it says area of triangle ABC is equal to half AB sine C. But in this case, we don't have triangle ABC. We have triangle BCD. Okay, so it's going to be easy to look at how we're supposed to do this, because we can see that AB corresponds with this and then C corresponds with that. So we're going to do the same thing. It's going to be small letter B, small letter C, and then sine of D. Simple as that. And then we have to simply substitute from there. So half into our B, it's this side, okay, which is K. And remember, we solved that K is actually 13 over 2 tan alpha from the previous question. And then we have C again, 13 over 2 tan alpha, okay. And then D, it's 2 alpha, so it's sine of 2 alpha. Now we have to find the area by substituting this alpha, which of 26 degrees. So it's 1 over 2 times 13 over 2 tan of 26 degrees times 13 over 2 tan of 26 degrees times sine 2 of 26 degrees. And then finally, you're going to use a calculator and punch all of this, and you're supposed to get 69,98 units squared. So this is the area of triangle BCD.